Hi, Mr. Manley here. Today I'm going to look at other trigonometric identities. Identities that you're familiar with already are, for instance, the quotient identities, the reciprocal identities, and the Pythagorean identities. And these are all used in proving trigonometric identities. And what we're going to look at today are some other ones, and we would use these in proofs as well, but we'll also use them in some calculations. The first calculation that I'm going to take a look at is this. Here we're given a value for sine x, and then we're asked to find the sine of 2x and the cosine of 2x. Now we're going to do this algebraically and trigonometrically. If you think about what it means that we're doing, although this is not what we would do, but just think about what it means. This sine of x is equal to 12 over 13. That could yield an angle, right? We could use the inverse trig function. So we could go what's the inverse sine of 12 over 13? And get some angle value for that. So I could get 67.4 degrees. And then we're being asked what's the sine of 2x. So that would just be plugging in this value for x, the 67.4 degrees. And that would yield a decimal approximation. What we're going to do here, however, though, is look at this exactly. So let's take our formula, and you could get this from a text or from a trig identity sheet, where we would get that for the sine of 2x, that's equal to 2 sine x cosine x. And that's a trigonometric identity that's just on a sheet next to your Pythagorean identity. Now I know that sine x is here. It's 12 over 13, right? So I know that the sine of x is equal to 12 over 13, and I'm being asked for sine of x here. So that's a direct one-to-one substitution. No problem there. And now the cosine of x, I don't see the cosine of x anywhere. There's a couple of ways that I could do this. I'm going to show you a right triangle method. So there's some angle x, right, that has an opposite over hypotenuse of 12 over 13. So if I solve for the other side, what would be the adjacent side, right? If I solve for the adjacent side of this triangle, this right triangle with x, I'm going to be able to find out what cosine is. So let's do that. All right, and we'll find that it's 5. So now I've got the adjacent side, so I can do cosine. We have to remember this little piece back here, right? This was given, if you read that in the beginning, that x is greater than pi over 2 and less than pi. So what does that mean? Let's keep that circled. So I've got that, and then also sine is positive because sine of x is 12 over 13. So sine is positive, and this is telling me that x is in the second quadrant. So what does that mean? I've got sine is positive there, and I'm also given that, well, I'm given that x is in the second quadrant. I don't even need to talk about sine being positive. X is in the second quadrant. And because you may know that all students take calculus. So if the angle is here in the second quadrant, the sine value of that angle is positive. The cosine value is negative. So when I do this x over here and do adjacent over hypotenuse, but the angle's in the second quadrant, so it's going to have a negative output. So that'll be negative 5 over 13. And then we've just got a calculator key in here. I'm not going to do that, but you could just take all of this and key it into the calculator and get your fraction. So let's also look at the cosine of 2x. And that's going to be a formula as well. I'll go to another page for that. Okay, we're looking for cosine of 2x, and that is cosine squared x minus sine squared x. Now, if you look at a formula sheet, we'll actually see that we have three choices for this side of the equation, for this right side of the equation. Actually, three choices, and you can see that on a formula sheet and understand what I'm talking about. So I just have selected this one, cosine squared minus sine squared. And then I just brought forward this triangle, and that we're in the second quadrant. I brought that forward from the previous page. So pretty simply, cosine x, looking at this triangle, remember, and we can also remember from the previous page, that was negative 5 over 13, and that would be squared. And then the sine of x was 12 over 13, and that would be squared. And again, I'm not going to simplify this to evaluate it, but that's what we have, and we would simplify that and get our solution. All right, so here's another problem. We're being asked to find the cosine of 165. Of course, we want to do this without keying it into a calculator. This looks similar to the problems that you might have done with the sum or difference formula, you know, when you were doing sine of u plus v, and then you were using that formula, and you were looking for two angles that summed to some other angle. So this is kind of similar to that, but a little different. So I'm going to use this formula here on the right, where the cosine of x divided by 2 is equal to, and then I've got this expression here. So all I'm going to do is take the 165, and I'm going to double that. So I've got, what is that, 330 degrees divided by 2. So I haven't changed the value. 165 is equivalent to 330 over 2, but now I've put this into a form that is that I can use here. I've got this 330 over 2, and then compare that to x over 2. So what we're saying here is that x is the x here is going to be 330. And then I can, from there, I can plug in to this expression that is given. Now it says plus or minus. Now just stop and consider that for a moment. Okay, so plus or minus, what we know is that the cosine of 165, so we know 165 is in the second quadrant, right? And what is the value of cosine in the second quadrant? All students, sine is positive, cosine is negative, right? So as far as the plus or minus selection goes, we know that this is going to be the minus version here. And then just plug in for x. So 1 plus cosine of 330 over 2. And so I can look on a unit circle, right? I can look on a unit circle and tell what 330 is. If I go here and go to 330 degrees and I get the terminal point is rad 3 over 2, negative 1/2, and cosine is the x value, right? So that's going to be negative rad 1 plus the x value for cosine of 330 is rad 3 over 2. And I'll go ahead and simplify this one, so some of you might like to see this. I'm going to multiply by 2 over 2. So it's going to be plus 2 rad 3 over 4. So do you see what I did there? I multiplied this by 2 over 2. And then that got rid of the fraction. I take another step. Here it looks like a negative. Remember the negative. And I got 2 plus rad 3. And then in the denominator, I've got the rad 4, which I can simplify to 2. And there I've got that's as exact as the value is going to get. So there's a couple of examples of using some of these other trig identities, right? That was the topic here, is other trig identities. And we looked at the 2x, at the sine 2x, and we looked at the cosine 2x. We looked at cosine 2x, and we looked at the half angle. This would be called a half angle formula, the cosine of x over 2. And these are some calculations that we can do. Then we would also be able to use these proofs. Right, go back to this one here. This proof or this identity here, that might be useful in a proof. That we might be called upon to use that identity to prove something. So there's a lot more to look at, and you can look at some examples in your textbook, and you can practice some problems and get a little bit more familiar with these and other proofs as well. I've by no means addressed all of the additional proofs that you could look at, but it's all the same. It's an expression equal to another expression, and you can use it for substitutions as appropriate.